This video is to help you understand multiple ratios with stoichiometry. So today we learned about in class what stoichiometry was, and how to convert from moles of one substance to moles of another. We had an equation where we had A plus B yielded AB2. To balance it, we had our coefficient 2 in front of the B, a 1 and a 1. So my moles-to-mole ratio was 1 to 2 to 1. Now I use my moles-to-mole ratio to convert between moles of one to moles of the other because moles are my pathway to convert between one compound to another and to another one. So we've now compiled two mole towns. You had your mole town, where you had moles in the center. You went up to mass. You had your volume and your particle. Okay, and this is for one compound or element A. Now to get to my compound or element B, I have to have a new mole town with a new area for mass, a new area for particles, and a new area for the volume. Okay. To get from moles of A to moles of B, I had to cross my mole-to-mole bridge, where I use my mole-to-mole ratio, which are just the numbers in the front, or my coefficients in front of my compounds in a balanced chemical equation. So I used my mole-to-mole ratio to get from moles of one to moles of the other. That way eventually I can go from mass of one down to moles across my bridge up to mass of something else. That's what eventually will happen, but right now I just need to practice going from moles of A to moles of B. So in your homework, handout 8-1, the first equation asks you if you have the chemical equation N2 plus 3H2 yields 2NH3. How are you going to figure out how many moles of ammonia will be produced if you start with 14.0 moles of hydrogen gas? It tells you you have excess nitrogen, so that means that our nitrogen does not have any effect on how much ammonia we make. We have tons of it. What's going to determine how much we make is our hydrogen gas. So I know that I'm going from moles of hydrogen to moles of ammonia. Now how am I going to get there? Well, I know that I have moles of hydrogen. I have moles of ammonia, just like on my mole town sheet. And to get there, I have to cross my mole-to-mole ratio bridge. So to do my equation, I start with what I'm given, which is my 14.0 moles of hydrogen gas. I want to get rid of moles of hydrogen gas. I want to go to moles of NH3. Again, always following my units to get rid of them. Okay, from my balanced equation of N2 plus 3H2 yields 2NH3, I know that my molar ratio is 3 moles of hydrogen for every 2 moles of nitrogen. So I put my 3 moles of hydrogen here to make a 3. I put my 2 moles of ammonia here, so there's 2. So to plug this in my calculator, I have 14 times 2 divided by 3. Which gives me 9.33 repeated with 3 sig figs, 1, 2, 3 in my starting number. I need 3 sig figs in my finishing number, so 1, 2, 3, cut it off there. So I have 9.33 moles of ammonia. Okay, you're going to do the same process for all the rest of your homework problems, and then tomorrow in class we'll be moving on to go from grams of something to moles of another.